Hi, I'm Tyler Hawkins, and my talk is called Letters, Optics, and the Visual Cortex. I'll be talking about fonts and low vision. I'll give verbal descriptions of my slides for accessibility, sometimes as I switch to a new slide, sometimes after I give a bit more context. The first slide includes a talk title on the left, and on the right is a rendering of the tissues and muscles of the iris. So with that, I'll go into a quick introduction. Reading is not a trivial task. We depend on it for social connection, access to information, and employment. 250 million rods and cones in your eyes detect light bouncing off of letters and then relay electrical signals to the language centers in your brain for identification and interpretation. Written language is an incredibly useful invention, but it's not perfect. We take it for granted. Type design specifically for low vision is a pretty recent phenomenon and has implications for how we think about accessibility in design. With this talk, I'll do my best to summarize the current scientific understanding of how we read and how that informs font design for low vision. I'll start with some background and align with a bit on the project that I'm currently working on. So who am I? My name is Tyler. I'm a designer living on the unceded territory of the Squamish Nation here in Squamish, BC. I've worked on a variety of projects with the Health Design Lab at Emily Carr. More recently, I started the Access Font project. We're working with the Disability Alliance of BC, the Canadian Accessible Technology Program, and a few developers to make a tool that tailors font files to very low vision. Much of this talk will come from the research and conversations I've had informing that project. My interest in all of this really came from working in visual design and wanting to understand its limitations. My pronouns are he and him. I do want to reiterate that my background is in design. I'm not a vision scientist. I think of this talk as a sort of practical literature review. I owe much of my understanding to conversations with people in the low vision community, as well as researchers like Sophie Beyer, Kevin Larson, Aries Arditi, and Elizabeth Russell Minda. My role is listening, synthesizing, and trying to be a better designer. Also, I'm going to try and keep this fairly high level and not get too deep into the weeds. I'm a bit of a nerd for this stuff, but it gets pretty nerdy. Anyone who wants to chat more, I'm always happy to. So with that, I'll start with a bit of background. What am I talking about? Sometimes it's referred to as visual impairment. I prefer low vision. The term most often describes a broad range of vision from 20/40 acuity to legal blindness from a variety of sources, including refractive errors, cataracts, glaucoma, diabetic retinopathy, and others. Some estimates suggest that people with more advanced low vision are employed at roughly half the rate of the general population and at half the rate of post-secondary education. Very generally speaking, low vision results in a variety of blurs and inconsistencies in the visual field. These graphics are reproductions of similar ones by Thomas Baum representing various sources of low vision, macular degeneration, glaucoma, and diabetic retinopathy. From conversations, I've found that many people with low vision read better on screen than on paper. It's important to note that the experience of low vision is incredibly diverse. What works for one person will not work for others. That said, there are some general takeaways. So fonts, type design. When we design or choose fonts, there's a lot to consider. Type itself is a centuries-old craft full of nuance and optical effects. This graphic shows the control points designers tweak to draw the Bezier curves making up the letters, here a lowercase g, representing just a small sample of the many decisions that go into making a font. One commonly held belief is that serif fonts, such as Ogg on the left, are more legible than sans serifs, such as WorkSans on the right. There's just not a lot of evidence to support this. Most studies show little benefit to serifs. Some argue that the added complexity interferes with the essential skeletons of the letters. Others argue that the inconsistencies in line widths, also called weight, obscure fine details with low vision. Many fonts for low vision are therefore sans serifs. Another commonly mistaken belief is that we read by word shapes more so than by letter shapes. Herman Boehme found that letters are more accurately recognized in the context of words, and that we read text set in lowercase better than text set entirely in capitals, suggesting word shapes play an important role in reading. However, this has since been largely refuted. Letters set in groups of non-words are recognized just as well, and the ease of reading lowercase has since been attributed to the effect of familiarity in practice. We hardly ever read text set in all capitals. This graphic by Kevin Larson shows an outline around the word shape set in lowercase, depicting its Boehme shape. Sophie Beyer, head of the Center of Visibility Design at the Royal Danish Academy, further breaks down legibility into the roles of familiarity and visibility. She describes visibility as the near instant perception of letter shapes, and familiarity as the influence of matching incoming perceptions with mental expectations of letter shapes to identify, name, and associate meaning to text. In her PhD, she discusses the studies supporting this. The way we design and choose fonts can be seen as directly related to these two factors. So let's talk about visibility and perception. The roughly 240 million rod photoreceptors in your eyes are sensitive to motion. Your 10 million cones are more sensitive to fine details. The center of your retina, the fovea, contains the majority of your cones, and you see clearest in the center of your vision. This graphic is a reproduction of a graphic by Sophie Bayer, depicting 3 lowercase days. The one in the center, representing the fovea, is clearest. The next, less clear, and finally the last, representing peripheral vision, is the blurriest. When you read, your eyes do not progress smoothly through text one letter at a time. Your fovea focuses on a few letters, identifying those just to the right simultaneously, and then jumps forward through unconscious movements called saccades. We center our vision on a few letters, identify them in parallel, and then jump ahead. This graphic from Kevin Larson represents just this, using a line to represent the path your vision might follow. Another effect to be aware of is something called crowding. Crowding describes how letter shapes influence each other, blurring them out and crowding the clarity of surrounding letter shapes. Type designers working on fonts for low vision often compensate for these effects by clarifying and improving the visual signals sent to the brain. Opening letter shapes has been found to reduce the impact of letters blurring in on themselves. Spacing letters apart minimizes crowding, so they don't blur each other out. This graphic shows both, highlighting the open shape in the lowercase e and the space between an A and a lowercase c. Letter weights also impact visibility. Light weights can blur out with low vision, and so can the negative space in black or ultra bold weights. I suggested avoiding them. So, familiarity. The eyes deliver electrical signals to the brain for identification and interpretation. We read through matching incoming visual signals to mental expectations of letter shapes. Expectations are informed by experience, practice, and familiarity. And so we read familiar fonts faster and with better comprehension than unfamiliar fonts. The problem is that many of the letters we're familiar with were not optimized for low vision. So familiarity, and on the other hand, enhancing letters for improved identification. Fortunately, there's been some work showing that familiarity can be learned and letters can be improved. Often this means increasing differentiation between letters. For hundreds of years, designers have relied on regularity to bring harmony into fonts, but too much regularity can lead to letter misidentification. In the same way that you often mistake zeros and capital O's or lowercase l's and capital I's, people with low vision do too. The subtleties which might help people with high acuity recognize letter distinctions can be lost with low vision. So, type designers exaggerate the differentiation between commonly misidentified letters. The tails on lowercase l's help minimize confusion between capital I's and ones. A serif on the top of the stem of the lowercase I helps prevent similar confusion. Dashes or dots and zeros help minimize confusion with capital O's, as shown here. Other choices, like choosing two-story lowercase a's and g's, help differentiate from letters that share the more common single-story O shape, as is depicted here. Paragraph text appears to be more sensitive to unfamiliar shapes. They can distract in slow reading. Because letter identification is informed by familiarity, all of this is a balance between conventional letter shapes and unconventional enhancements. So what? How do we work with this as designers? So the first thing I'd recommend is to choose fonts that include many of the features I've mentioned. Places to look I recommend include Atkinson Hyperlegible, Fontsmith's FSME, Lexend, and also WorkSans. Those last two weren't designed specifically for low vision, but they include features that work in many of the same directions. This presentation and Magnify itself actually both use WorkSans. It's great. This image is a blog post I really like that reads Atkinson Hyperlegible font may be pretty good if your granny can't see well. Find it, check it out. It's a great story from a guy just helping his grandmother. The second thing I recommend is involving people with low vision in the design process whenever possible. Also do your homework. Look out for more research on this stuff. It's fairly new and it's evolving, but there's really interesting work being done. Lastly, I do have to mention the project I'm working on. We're taking many of these techniques and making them adjustable. They're great fonts for low vision. They're great font customization tools. We seem to be among the first to be releasing a free tool to do both. This image shows a draft web page depicting our browser extension. So that's my talk. Thank you to Magnify for organizing. Thanks for everyone in attendance and everyone who's contributed to the Access Font project. Don't hesitate to reach out if you have any questions. Be more than happy to chat. Finally, here are a few of the resources that I mentioned in case you'd like to take a closer look. I can get you a more proper citation if you'd like as well. Best. Thanks.